Good afternoon. I hope you hear me, the participant.
Yes, thank you.
Okay. My name is Florin Ruska. I'm from Romania. And now we will start the session 80, solid test, which is dedicated to transport at regional and national level. We have a beautiful paper to be presented in this session. I hope you like it, and I hope you have a question to interact between us and know each other. The first paper will be mine, so we accept to start the presentation. We don't have a presenter, no?
What?
A presenter. No, it's okay. I hope you see.
Yes, thank you.
Okay, so as I tell you, my name is Florin Ruska. I have a paper with title "An Assessment of Road Network Topology and its Influence on Port Accessibility in Romania." We have 6 authors. Most of them are PhD students, some of my PhD students. I came from National University of Science and Technology Polytechnica from Bucharest. It's the biggest university from Romania. We are engineers. Well, we have also another type of bachelor license, but the main domain of our research are on engineering. My faculty is Faculty of Transport. So if you like what I present here and you want to visit us, you are welcome in Romania, just write to me. My paper from today will be dedicated to some research made in the domain of network topology and some impact model to evaluate the accessibility and variation of accessibility depending by the links, the critical links of the network, if these links are working or not working. My presentation starts with ports because my analysis will be in connection with ports. Ports, as you know, are a main gate between maritime transport and land network. And ports are important for to have a good logistic chain. In case of Romania, the Romanian have 4 maritime ports. One of ports is located near Ukraine and don't have a connection with land network. It's just transit ports. It's located in Danube Delta. The other 3 ports are in the south of maritime area. These ports are dedicated for freights. We don't have passenger lines, few lines. So the main activity is dedicated for cargo transport. The connection between these maritime ports and their hinterland in the national territory of Romania is through the free bridges, because if you look to map of Romania, you see a bottleneck, and this bottleneck is also separated by Danube River. So it's very straight, but also we have a big river who separate the maritime area by the rest of the land. On this river, we have only 3 bridges. So the malfunction of one of the bridge have influence on travel time from maritime ports to other areas of Romania. Okay, so um, as I tell you, 3 bridges. We have. I give the name of the bridges. It's Fetish Bridge, which is a bridge located on a highway, the most important highway to connect the maritime area with our capital, Bucharest. And two secondary bridge. Hârșova Bridge is first bridge, but is located on national road. And Brăila Bridge is a new bridge who makes the connection with Moldova area or Ukraine, which is most known by you. Why these bridges are important? Because provide access to maritime ports, and because the freight flow who use this bridge is very important and are critical for national economy. So my team in the previous period have some research in this direction, but not in our paper. Some research are made on port area. We build some simulation to see the importance of land network, to see how can be optimized the activity inside of maritime terminal, and how we can use the land near port because it's limited. So some research are in this part. Other research are made on road network, national road network, to evaluate the reliability and the vulnerability of road network. And this is our first research to connect these two domains, so maritime ports and road network reliability, to see what happening with accessibility when some links have a malfunction, something is not working. So the objective of our research is to assess the influence of road network topology. To do this, first step was to identify the critical road infrastructure. In our case, will be the bridge over the Danube. To measure accessibility and in a baseline scenario, and to see some variation in a simulation scenario, to evaluate the role of Danube Bridge, and to see how we can help the resident, what measures must be implemented to help the road network savings parameters.
Okay.
Accessibility. When I start to study accessibility 20 years ago, we start with some typical models, Hansen index, to calculate accessibility, like sum of function, to calculate some cumulative opportunity model. This was our first research. More complex research was using elements from graph theory. We put the physical road network to a graph and calculate cost matrix, shortest path, critical section. I know in Romanian, in English, I don't find the word. But in last time, because we start to work with macro simulation models, we have dedicated software like Transcad, Visum, Einsum. We start to study accessibility using this transport model, which are include a macro simulation model inside. So the results are more, how see, more graphical, and we can see for each area which are the parameter, travel time, flows, and other parameters. For the experts from transport, this type of graph. Transport model include three sum models. We have a network model where I build links which are associated with roads. I put capacity, I put maximum speed, speed at free flow. I insert parameter for volume delay function. I have a demand model with result of from which I obtain traffic assignment, and of course I have an impact model. In our case, will be bridge failure scenarios, isochron generation, accessibility assessment, and results comparison. My model, my macro simulation model, is built on a base model, which is Romanian national transport model, was built, I believe, 6 or 5 years ago. So I take this model and I correct because in time 1,000 new kilometers highway was developed, one new bridge, another flows appear between cities. So I recalibrate this model. If you look to this map, you see our road network in Romania is structured around the radial configuration, because all the, like in Europe, all the roads go to Rome. In Romania, all the roads go to Bucharest. So this is good for Bucharest, but it's not good for other locations. In our case, the maritime ports, because it's the highway. It's all connect one connection between maritime and the capital. Okay, these are the bridges. Now, okay, so we have three maritime ports: Mangalia Port, Constanța Port, Novgorod Port, and we have three bridges: Petești Bridge, Hârșova Bridge, and Brăila Bridge. If I start to build my network now, I will put one road, one port, one bridge allocated to every port. But in reality, all three bridges are allocated to only, all three ports are allocated to only one bridge, because this is a road network topology. So our two bridges exist, but these bridges are not used to their capacity. Okay. So I built 7 network scenario to see what will happen. We have a baseline scenario when all bridges are working, and other 6 scenario when 1 or 2 bridges are have a malfunction and the circulation are stopped. The technology will be using isochron. You know, isochron is the area when which can be reached in specifically the travel time from starting from a interesting point. Yes, and these are some results. So this is a baseline scenario. This is when all bridges are working. We have isochron for 3 hours, 6 hours, 9 hours, and over 9 hours. Why I put this border line, because in Romania from 6 hours to 9 hours in flight transport you need is transfer from one driver to two driver, or from 1 day to 2 days. So it's important to know where is the border between 6 and 9, where is the border between 9 and over 9 hours. Because from economical point, it's very important to have one driver, to two driver, or to make 1 day to 2 days. This is the most, this is scenario where is, we have the largest accessibility loss when is this bridge is closed. And these are the results for all scenario. You see, when Feldage bridge is closed, we have the most lost accessibility. And this is for all time. So, discussion, road network have implication over transport network parameters, implication. The topology is very important because some links can be more critical like other links. How we can see this? Using some macro simulation software, which are useful for transport engineer. And also using this software, we can see if the network can support the supplementary traffic when some link is closed. It's so called reliability of transport network over capacity. Some research. And conclusion, sometimes network topology of network is more important, like direct distance between 2 points. The capacity and the reliability of the links is very important for to have a good parameter of serving for networks, and some results can be used to prove for national resident to build another highway or to build another bridge if it's required. So this was my presentation. I hope we thank you. If you have questions, I'm glad to.
I have a question.
Okay. Thank you.
In this scenario, you consider the transportation way from port to inside of country. Okay, it's importing materials and the things. Do you have considered the outside way and the production that something that is produced by the country and exported by port, and this way, this inverse way from the interior in the after 10 hours region, some product or agricultural productions is put in a truck to send from.
Yeah. Not in this research. In this research, I start from maritime ports going to territory. I have another research, but not now. When I try to calculate to see the hinterland for the weight for grains production, because I don't know, just low. The weight production in Romania is somewhere here and here.
Okay.
So if I have here another weight production, it's more easy for this part to go to another port from Croatia.
Okay.
Because the distance is very big.
Okay.
And I tell you, The economic actors all the time calculate the cost. If they need two drivers, they say, okay, I'll go to another course.
It's nice because in Brazil, our case, for example, the way is more from the internal side of the country to ports, exporting the crawl and all the others.
And another problem is now in summer, because in summer, in weekends, the trucks don't use the highway, because in this part,
Yes.
because we have a lot of tourists.
Yes. In Brazil, it's the same, long.
Yeah. And also train, because we have a lot of passenger train, and passenger train have a priority on railway infrastructure. The freight train don't have opportunity to arrive in time in maritime ports. So yeah, in summer we have a lot of problem with connection of maritime ports, but I don't know. This can be an idea for the next article.
Thank you.
From online, we have some questions. Okay. Yeah. Sorry.
Somebody has a question.
I have a question. Is
Yes.
it possible?
Yes.
Okay, thank you for your presentation. There are many considerations, but just one clarification. If I well understood, you declared that you used Visum software, VISIM, the microscopic simulation VISIM.
Visum is for macroscopic. Visum is
It's macro?
for micro. Yes, macro.
It's macro. Okay.
Yeah.
Okay. So I don't know if you this. So the network, if I well understood, considered also the level of congestion on the link generated by the closure of the bridge.
Yes.
Is it right?
Yeah. For to build macroscopic, I start from national models, as I tell you,
Yes.
with some calibration, because now our transport ministry want to renew this model. So I start with my previous model and recalibration, put new links inside the model. Yes, so the value are the mean values of, as I tell you, in summer, all is changing. I can have peak flows who change everything. I can have some rules in weekend, Saturday and Sunday is not allowed to cross highway bridge.
Okay.
So
No, because I don't know if is it possible to if you think to some possible mitigation measures like regarding each scenario disruption. I don't know if it could be analyzed, defined any mitigation measure after these results that you have obtained simulating this scenarios disruption.
normally, when something like this is happening, the national authority gives some indication to use another bridge. This bridge is closed, but people here and some people follow this indication. Some people don't follow this indication. I don't know. We are late in we don't like to somebody tell us what to do. But yes, mitigation.
Because these three bridge seems very three choke points in the national
yes, it's a critical.
in the country. In the country seems to be, I don't know what is the situation in Romania, but seems very crucial nodes of the road network. Very okay. This is general consideration. We can for now. Thank you for
Thank
your
you.
presentation.
Thank you. For us, these bridges are very important because until 2 years we have it only two, and our government pay 1 billiards, 1,000 of billions euro to build a new bridge. So the price is very high to build new bridges. And we know that we understand the importance of these bridges because it's Danube is very large river, and but we are because monies are big are required a lot of money to build new bridges. It's not so easy. For me, it's easy to say we must build a new bridges, but in reality, it's not so easy.
Okay, thank you.
Thank you. Okay. Now we'll go to the next paper. Okay. Comparison of container routing in free shipping networks. And
Good afternoon. I'm Orlando Marco Belcore from University of Messina. Just a few seconds to share my screen. Tell me if everything is okay. Do you hear me?
yes.
Oh, okay. Thank you so much for being here and sharing this conference session. Of course, okay. Here we would like to introduce as a representative of this group of research from the University of Messina, a part of a job that you also have a twin paper that we already presented. Also in this time we have to look like a little bit opportunity to make a comparison. We are focusing on container routing because of course, as most of us has known, how important is container transportation worldwide, and how the fragmented of the last year severely impacted how maritime ports work, how to increase the volatility of operation. So by then we say, okay, what we can do to simulate and to make some comparison between what usually operate on other service with respect to what is usually happens at the container terminal, considering origin destination for each group of containers, focusing on the reliability of transit time and the reconstruction of each path and the transshipment operation. Of course, as far time is a matter, but it's not always only a matter of time, we concentrate here on temporary routing because, of course, sometimes need to reroute the container to achieve a more comfortable travel time and transit time to reach the destination. So basically, we are going to compare two solutions, the CSA and the Raptor model. Here, just a quick outline of our job. I have, of course, introduced context and motivation. Then we are going to see the modeling comparison methods and the model we have already used in this case of study, and then we show results and discussion about what could be the future work upon this team. Of course, as first we focus on some gaps from the literature, basically thinking about how relevant is rerouting this kind of transportation to achieve a good operationability and avoiding too increasing problem with volatility of the to reach the final destination, or just increasing operation in such terminal. So in basic question for this paper are what can be interesting seeing from these two from to this algorithm, what things they perform better, and what is possible to compare about this and understood on travel of container travel. To do this, we start from service data from the CMA CGM that are open, so you can always discuss this timetable and use it to reroute. And then we compare using the classical canonical representation, just to put in sequence port and service. And then we compare the two methods that we are going to see using this canonical representation, and using as discriminants between solution some indicators and of similarity that compares some part of the path, or just the number of transshipment and difference number of transshipments that the two solutions suggest out to be more reliable the whole trip. So the core idea for the first one, the connection scale algorithm, is like to operate considering each connection from port to port, considering departure time, the arrival time, the service line that is going to operate, like, and of course time for departure and arrival. So it means that we need a chronological scan of the area of the port and the consignment, and we just focus on feasibility of waiting time and transshipment for each of these route. On the other side, the round-based public transfer routing, or Raptor as we call it before, computes the optimal routes iteratively, relaxing each round, assuming the possibility or the opportunity to make transshipment up to the final destination. Of course, it supports a need to control number of transshipment, not to let the algorithm not to converge. It is of course structured in round. As we say, we have the origin part of the service, and each time transfer is necessary, the algorithm create a new round up the destination. So we are aware about temporally consistency of the operation along with all the transit. As I mentioned before, we use the data set for a scenario, so it compares some lines with each one frequency, number of ships, and the number of ports, and the ideal routes that is scheduled for it. And we try to organize 3 different scenarios, and small case one, and medium one, and the third one that is bigger. It's also to try to understand which could be the limit of use one or both of these algorithm in time in scanning, or reaching to a solution if it becomes too much stressful for it to make a converse, to converge, and make it let you to operate too long processing time. Of course, as to test the solution, we use similarity measure, I said before. So the first one is a port sequence similarity, that measures the similarity between the two routes, and so consider all the ports that are visited. The same sequence of port visited. The node-based similarity, that is based on the Jacquard index, that measure the overlaps between the two sets, but don't care on order of the sequence, as we said before, post-sequence similarity. And as I mentioned before, we also tested the two algorithms consider the number of transshipment that they suggest us, because of course each time it's necessary to transship, it means that you can be more familiar and can be more strict with operation at the port. So it make me means that you can be affected by delays or other operation risk that make all the situation that could be risky than a less elaborated one. So, as far our objective is assess the impact of this routing and computation, I show you just the share node, and here we are some results that we achieved. So, as first we said we focus, as I said, on computational effort. We say that usually the scan one is faster. Also increasing. So on the other side, the Raptor can have some problems on make the same solution quick as quickly as the other one. But of course, it's not so it's so stressful, at least because of course we are considering like more than 1,000 connection. But of course, if we consider how exponential rate grows, it's like, okay, it could be a problem. And if we focus on what we like the most, on average transit time, travel time for each OD, we see that in the small scenario, it's 2-1 are quite equivalent. But in the other cases, Raptor seems to be more stable. What is most interesting is that using the second one, it makes us to strictly limit the number of transshipment. What is important the most is like, for example, in scenario 3, the biggest case, we reach some cases where the number of transshipment, or the maximum number of transshipment for the CSA becomes very high. It's like 15. So it means that to converge, make routes that are always longer and fragmented. This can be the classical case where, as I mentioned before, it's important to reduce number of transshipment, not to avoid that other problems related to operationality at port can be exploded during the origin destination travel. Of course, we can see also the other last one, similarity measure on Jackal and length of the path, the visit port. Results are similar, but it's important to notice how as much the scenario increase in complexity, they both start failing in reproducing a good performance. But of course, what is maybe interesting the most is also make the comparison with the previous work I mentioned before. So we compared the solution. We try to use two similar scenario for both. Some things were exactly not the same, but it can be let us to make a comparison between these. In the other case, we, as we say, this the green line. We compared the line based and time spent algorithm to test, and of course the results we achieved are simply better than the one we see if we compare the similarity decay across the different scenario. This is more or less what we observed up now. Of course, in this case, we mainly based on algorithm and its logic. Now, in the previous one, we were more focused on network representation. what is interesting the most is like that. Of course, we are just focusing on scheduled time and real time, in maybe data integration with other probabilistic measure on how collapsing on bottlenecks at each port really assist can make us to find other solution. What is interesting the most from this comparison is that the CSI is severely penalized by the excessive number of transfer, and of course, as we say, the similarity decreases as further network complexity increases. So it makes us that maybe considering we are just working on CMA, if we consider more companies and more connection, it may be really difficult, maybe also for the Raptor to converge to a solution. Thank you for your attention. I'm trying to interrupt the presentation. It's okay?
Thank you for your presentation. Yes, so very nice presentation.
Thank you so much.
If you have questions. Yes, Professor Mussolino.
No. Presenter. I'm the next presenter.
You activate.
I'm preparing for the next for my presentation. Yeah. I know the work of Orlando. We worked together in the project that I will describe in my presentation. So I know very well his work and of the research group in Messina. So I have no question for him.
So I have a questions because I'm chair, so I must put questions. So you think to some application in real world for your algorithms, which is more reliable to be used?
I think that if we start introducing the uncertainty and the feasible the case in effective respect of scheduling that each port makes, is really difficult to understand. At the beginning, it seems that the other two ones that I mentioned, the line-based and time expanded, should be more simpler to converge and make less that each solution they find is like more reliable, because of course as I mentioned before, if we look into the average number of transshipment, here the number is really stressful, is increasing. So if we also add some errors at each one of these transshipment and some penalties, it makes me that for example is really difficult to be certain about how to use the CSR only and not benchmark it with other source. So I think at the moment maybe the no one of both I like the most, but there are the two other.
Okay, thank you. Another question, if you have it. If no, thank you, Professor. We go to next paper, which will be analysis and interpretation of attributes affecting ship type time in container ports. Yes.
Can you see my slide?
Yes.
Yes. Thank you, Mr. Chairman. I'm Giuseppe Musolino, working at Università di Reggio Calabria, south of Italy. In this presentation, we summed up the research work executed during a 3 years research project that involved many colleagues, some colleagues of the University of Reggio Calabria, Paola Panuccio, Corrado Rindone, Francesco Russo, and Antonino Vitetta. The topic of the research was focused on container port. We know that there is a classification in the literature based on the UNCTAD approach that classify ports, existing ports, according to the criterion of generation, and we focused on the research on container ports that is, according to this classification, a third generation port, which are ports that not only handle containers, but also have hinterland where the containers are manipulated in order to increase the value added of the freight. So they are not only a center of cost, but they are value-added generators. One of the key indicators about the performance of these ports is the ship time import or vessel time import. Is the time from the ship arrival in proximity of the port until included the waiting time until the ship leaves the port after having done the loading and unloading operation of containers. So this is according to us a key, as I said, a key variable, also testified by the work done by the World Bank that uses this variable to estimate the container port index, which is an aggregated index based on this variable that classify container ports all over the world. So these are the two research questions, or to try to understand, which are to highlight which are the elements or the factors that affect this time, ship port times, both at port level and at country level, and also to calibrate functions that put in relation this variable with emerging attribute or factors. The research was done at considering different levels, as you can see in this picture. One aggregate level is considering this variable at the country level, and the information were obtained by global databases from UNCTAD, the World Bank, and the global economy. While there is also a more disaggregate level that consider the ports, each port, group of ports, and also a third level consider the single port. In this case, the main information came from AES data. So we obtained this data by means from some available platforms like Marine Traffic, Vessel Finder, and other platforms that allow us to estimate this, make some individual estimation of this variable for each ship in a selected port. Now I will show you which. So according to these elements, the literature is the presentation is articulated in 4 steps: a brief literature review and model specification, Then a focus of model calibration we have done both at country and port levels, and then some conclusion and further research. The literature, just to say that the research rely on transport system models, and in particular on the elements concerning the supply models. We have two classes of models, aggregate and network model, that can be diachronic or static, synchronic or static and diachronic. This is an example how, for example, a ship trajectory, a trajectory of container ship arriving and exiting from a port could be schematized on the right part of the slide with a graph that describe and also represent the temporal components of these operations. And however, these elements are being considered in aggregate way, because we consider the entire variable, the entire value of ship time import, and we tried to, as I said, put in relation with some attributes, considering both the country level and the port level. And this is the optimization model based on linear regression models. I would like to go to the main results of the model calibration. Firstly, at the country level, we gathered information related to about 50 countries in Europe, Africa, Middle East, and Far East, from as I said, the different databases, and the variables were grouped in these different classes. The variable related to the ship, to the port infrastructure and services, to the level of dotation of ICT of the country and the economy. As I said, this is variables aggregated at the country level. And this is an example of the attributes we have considered. We made several specification of the model and several calibration. And after, at the end, we focused on three main factors, which are the maximum capacity of ship, which is a proxy of the level of dotation of infrastructures, port infrastructure of a country, the number of ship calls, the total number of ship calls per year, for example, these are data per year, which is, according to us, a proxy of the efficiency of the port operations. And then another factors, which is the ICT technology index, which is also here a proxy, general proxy of the level of dotation of the ICT equipment of a country. I show you just some trends. For example, if the maximum ship capacity increase, the port ship times decreases. That means that the country has a greater dotation of infrastructures, port material infrastructures. And also the technology index, the increasing technology index cause a decreasing of port time. So this means that the diffusion of ICT tools facilitate, and the level of digitalization facilitate the interaction among port stakeholders, as we saw also in other research, that we have done at this aggregate level, and also the number of ship calls also increase. The increasing number of ship calls determines a reduction in port ship time, and this should be also, according to us, an indication that of major efficiency of port services. I go to the results of concerning the disaggregate level. I mean the level of analysis considering individual ports, and here we consider some ports of Mediterranean and Northern Range in European Northern Range, considering a pilot database of ICE data. Also, in this case, we have a classification of attributes according to the ship characteristic, the ports, the geographical area that of the port, and also of the maritime services, and other characteristic of the service that we call the chain. Also, we have several attributes here, and then I would like to show you just some reference value of ship time in ports extracted by our sample database. The number of observation, as you can show on the left column, is low because we extract this data just from open access information. So the extraction was done manually, observing the trajectory of ships. And we can see that there are some average values of concerning the Mediterranean ports and also the Northern Range ports. From this database, we also could draw some general indication about some factors. For example, the calibration of results highlights that ship times related to southern and northern European ports are greater than African ports, which is now today the only Tanger Med. Tanger Med is the port that performs better, has the best performance in our database. And also another elements concern ship capacity. From the calibration results that ship times of port times for a ship having greater capacity or lower than port times related to ships with less capacity. And this could be interpreted also by the fact that in the container ports, greater motherships as priority, so there are no waste times associated to handling container in the biggest motherships. The third element that we have done was a focus on just two ports, two container ports, which are Gioia Tauro, which is a port not far from my town, Reggio Calabria, in Calabria, in the south of Italy, and Piraeus in Greece. They have similar characteristics. They are main transshipment ports where a great part of container of or transshipped. There is a low interaction with the land networks, and also some further elements related to some variable related to the maritime services. In this case, geographical area means that is the geographical area served by the maritime service of the ship calling Gioia Tauro or Piraeus. And we see that, for example, ship times port time for ships connecting Indo-Pacific, Mediterranean, and North Sea present times lower than higher, than the ships offering services for Atlantic area. And also we consider also another service variable, which is we call it the chain, which it is associated to the previous and next port call of the ship. And we see that in this case the ship times are higher if the both the previous and next port call belong to Mediterranean. So this could be associated to the fact that the service is related to feeder ships and operating inside Mediterranean. These are the main elements, very aggregated elements. There are other line of research inside this project, but we have no time to talk about this. Just some conclusion. We think that this variable could be a synthetic benchmark indicator for evaluating port's ability to efficiently handle container flows, and we know that this variable is the reference variable of the container port index by World Bank, also in this last release. We have done a multi-level approach in analyzing based on aggregate level at the level of the country and also at the port level. And also we identify some reference attribute that could support the decision makers, for example, at the national level or at the infrastructure ministries, or at the port level, like port authorities, to identify and prioritize investments in more critical areas in order to increase this value, that because we know that container ports are very work in a very competing environment, one to another. For the future, we know that the ICE data sample is quite small, so we need to increase to obtain further ICE data related to the same port we analyzed and also further port in order to make an extended comparison. And also we would like to, at the country level, rerun the models for more recent data in order to take to account the effects of what happened in the recent global scenario. Thank you very much for your attention.
Now we have also a microphone to hear our applause. Thank you also for your nice presentation. If we have questions. Domenico? No?
No, I'm the next presenter.
I understand. Okay. So I must put questions. I see your future development will be to collect more ICE data. I understand
Yes.
correctly. But how you obtain the actual data, ICE data? It's not easy to obtain this type of data. I know. I believe the most easy is to have a ship with ICE transmitter.
Yes. No, unfortunately, we tried along this project to buy this data from a global provider, but in our experience, we did not manage to obtain this kind of data as structured as according to the need of the project. So this negotiation failed. This is perhaps unfortunately was not successful. This negotiation. So we need for a mitigation as a mitigation measure during the project. Develop the model upon the smaller, very small data sample, because we know that we rely upon 300 or 400 of observation. Our initial that we gather manually from the open access parts of the platforms. So we understand that there is the need to consolidate this data for as was our wish to with the greater number of ports and also greater number of observations. Because there could be a great variability upon the time import due some contingent situation inside the port, like congestion. So the waiting time could increase relevant for one ship before entering the port and reaching the berth, the operation area. So there is more room for research
Yes.
in the next project.
Yes, maybe some AI agent will help you to collect this type of data.
Yes. Also,
Who knows?
Our objective was to buy. We have a specific budget for buying from one of the greatest provider in the world. But this operation, the database as we need was not possible to obtain.
Okay, thank you again, Professor Giuseppe Mussolino. We'll go to next.
Thank
you. Pleasure. We'll go to next paper, which will be environmental sustainability of railway corridors, case study of Italian high-speed rail. I say correctly?
Yes. Do you hear me? You see my
Yes.
screen?
Okay, the floor is yours.
Thank you, Mr. Chairman. I'm Domenico Sgro from Università degli Studi Mediterranea di Reggio Calabria, Italy, and I'm going to present a case study which regards the estimation of carbon, of the impact of passenger mobility choices in a context of intercity travels by means of a methodological and a tool that consider the carbon footprint, like I said, in the intermodal competition The problem relies on two different main situations. On one end, we have the growing of the demand, the growing of the average, like you say, you can see in the left side of the chart, and the growing of the infrastructure lines all around the world. And on the other side, we have the environmental impact of the transport sector, that is the almost the 30% of the total impact, and also the global annual mean temperature that is growing. And so, concerning the sustainable development goals, this study is relies in particular on goal 13, and with an indirect impact on the goal 9 and 11. Another very important contribution to this issue is the LAR paradigm, that consider it is an approach that that support the choices in the programming phase. In particular, is it has 4 components: lean, agile, resilient, and green. This study relies on green component, that is the ability to impact positively on the environment. And on the other hand, it's important to underline the emission assessment framework composed by 3 components. In particular, this study deepened the tank to wheel component, that concern the operational phases of a the transport mode. This is the outline of the presentation. The first part concerns the method, the specification of the method. In particular, the method is composed by 5 main steps. The first is the identification of the United Nations guidelines, that are the sustainable development goals and other guidelines. Then the second phase concerns the specification of the GHG indicator method. Then there is the providing of the demand data. The fourth step concerns the specification of the modal shift scenarios, and then the calculation and the estimation of the GHG of each scenario. In particular, concerning the UN guidelines, this study aim is to calculate the indicator 13.2.2 of the goal 13, that is the total greenhouse gases emissions per year, and it consider specifically the global warming potential, and includes all the gases that you can see on the slide. In particular, the carbon dioxide, the methane, and nitrous oxide, that impacts more than the others on the operational phases. This slide concerns the method specification specified and proposed in this work. So consider the demand flows. The second step concerns the calculation of the carbon dioxide equivalent of each mode, that is mode of transport is dependent of vector of attributes and other characteristics. And then the third step that is the comparison between the actual scenario and the hypothetical scenarios. In particular, this indicator of UN relies on IPCC guidelines of 1999. This is important because led the indicator to different greenhouse gases, like we saw before, to the global warming potential, so a realistic situation. On the basis of that, we specified and utilized the eco passenger model provided by UIC USA 2016 that concern the calculation of the emission that is calculated by two components, activity data and so-called other factor. The activity data from the eco passenger model is calculated by a query setup that consider this a quantitative attribute. Consider, for instance, the route, the date, the time, so a real situation, and other specifications such as for the alternative of rail, car, and rail, and other specifications. So we have the quantity of CO2 emitted, and the other factor is a parameter that converts the activity data to GHG quantity. The demand flows observed are extracted from telco data, provided by telco data, and extracted from different simulation. And we have three scenarios. The first one is actual. The second one is 10% of demand shift from air towards rail. And the second one is 10% of demand shift from rail to air. The second part of the presentation concerns the case study. The experimental test site is Italy, and the relationship Rome-Milan that consider the two main transport modes of this relationship. That are high-speed rail and air, and the transport companies involved are Trenitalia, NTV, and ITA Airways. You can see also other characteristics of these flows, of this link, because this is the main link in Italy in terms of flows and services, as you can see. Do you hear me? Do you hear me?
Yes.
Now yes.
Okay.
Yes.
Okay.
Everything okay?
Okay. This is in this slide is reported the query request that we specified in order to obtain the activity data. As you can see on the left, there are all the characteristics of the query. This is a real situation. And on the right, we can observe the results of activity data in terms of CO2 equivalent quantity emitted by train, car, and air. In this study, we consider in particular carbon dioxide. By considering the telco data, so the passenger demand flows, so we can estimate the total emission for mode and scenarios, and these are the results. And in particular, as a discussion, we can identify then that the second scenario, that is the scenario for rail, so a split of demand, diversion of demand towards rail, is the greenest one. So we can identify as a result that the diversion allow to save a huge quantity of GHG emission compared to all the other transport modes. And as a possible research direction, we can extend this method to other connection in Italy, north-south, and other national contexts, and we can lead a more in-depth focus on the impact of demand component on this study. This is all. Thank you.
Thank you for your interesting presentation. If you have questions. Somebody? If not, I will put to you questions.
Yes.
I used Eco Passenger 10 years ago, I must tell you. How you insert in model the difference between high-speed train and normal train?
Thank you for your question. Is it possible to identify the high-speed train with the query request, because the Eco Passenger software identify exactly a run, a rail run. So in this link Rome Milan, it is possible to identify an high-speed train.
Okay, I believe now you are in train. Okay, another questions?
Yes, please.
If not, we'll go to the next paper.
Thank you.
Which will, thank you, Professor. Lean approach for high-speed railways, general elements for extending the Italian network in the south. We have the presenter. Professor Antonio
Yes,
Russo,
yes.
welcome.
Yes, so I'm sharing the screen. Please let me know if you can see my slides full screen.
Now it's okay.
Okay. And are you seeing my slide moving?
Yes.
Okay, perfect. So these two tests are mandatory at the start of a presentation. So if you're hearing me correctly, okay, this presentation, the title is A Lean Approach for High-Speed Railways, General Elements for Extending the Italian Network in the South. The authors are Corrado Rindone from University Mediterraneo of Reggio Calabria and Antonio Russo, me of University of Bennacore. The work is a part of a broader work on extending the large paradigm to HSR. In general, these are the four parts of this work. As was previously said in the previous presentation, the main topic is connected to Sustainable Development Goals 9, Industry Innovation and Infrastructures, especially to Target 9.1 and Indicator 9.1.2, that refers to quality of infrastructure to support economic development and accessibility. And also we have to consider obviously the definition of transport given by United Nations 2015 of transport system as not an end in itself, but rather a means that allow people to reach their need. So in general terms, the work is focused considering the general plan for expansion of the European HSR network and obviously the Trans-European Network on Transportation, which last iteration was regulated by the normative in 2000 by the European regulation in 2024, and we are specifically placed in the Scandinavian Mediterranean corridors. We are going to see in general terms the most important topic connected to the development of HSR is obviously the reduction of travel times in order to create a European high-speed network interoperable and integrated into multimodal system of European Union. In general terms, the large paradigms the tentative is to consider large paradigm as a paradigm that large, lean, agile, resilient, green, the main elements was being recalled in the previous presentation. So as an approach that may be implemented in the program phase between the planning phase and the design phase. So the four components largely is an acronym. We can repeat it considering another time the presentation of Domenico Sgro about the last component. This will be about the first one. So lean connected to cost and waste reduction, agile to ability to respond to demand, resilient to ability to respond to risk, and green to the reduction of ecological damage in the case of HSR, both in operation and in construction. And we want to focus on the lean component of the large paradigm inside the HSR programming. The main objective of this paper is to investigate the main possible implication of lean component for HSR planning of the HSR planning of a new HSR line. And we wanted to propose to study what are the potentiality of this approach, considering an analysis in southern Italy. Southern Italy is a context characterized by heterogeneous infrastructure quality and generally a weak transport system compared to the standards of both Italy and European Union. The case studies used to evaluate the network performance and to identify structural gaps and missing links. So, in general terms, lean approach in HSR may be referred to infrastructure and services. Infrastructure and services, at a certain point, they are variably interconnected. We can refer to Campos and Arras 2009 to understand how infrastructure and services interoperate among them, because each country has its specific regulation, even in interoperability of systems in Europe. And we want to understand both the infrastructure and services implementation of lean paradigm. General terms, from an infrastructure point of view, we can make first another classification between the horizontal alignment and the vertical alignment. Both of them refers to the possibility for high-speed rail to be competitive with alternative transport system, reducing the distances. For the horizontal alignment, the reference is to the free connection, the optimal direct connection, the conventional rail connection, and high-speed rail connection, while the vertical alignment refers to terrain profile and the altimetric track. On the other side, the service connection refers to four main elements: study area, based on the distance considered, the classes of rail services, railway operators, and network nodes considered as a reference of the study. We want to share some case studies for the horizontal alignment criteria for the infrastructure analysis. We referred to 3 countries, Italy, France, and Spain, considering several HSR line on different part of the 3 countries considered. And in general terms, evaluating the values of the linear extension of HSR lines, the conventional line, and the straight line, so the 3 lines we referred to in the methodological slides some slides ago, we considered how there is an average reduction of 15% from conventional line from HSR line to conventional line, while on the altimetric side, we can consider how in generally Italy shows lower value of gradient compared to France and Spain. From a service point of view, we considered the expansion of several tools of network analysis in order to evaluate the ex-ante characterization of the current infrastructure and services of the current service systems, considering 3 main indicators: the degree centrality that allow to evaluate the number of connections, while the strength centrality measures the number of connections of each node weighted by a quantitative value that may be, for example, the frequency, and the eigenvector centrality measures the node score, considering the importance of the connection, not only the position, but also the connection of the node with which the generic node is connected. So from a general point of view, the degree centrality also may be constrained by specific threshold like specific travel times. These indicators will be applied to 3 different case studies in southern Italy. First one being a national case study in which we compared the degree centrality, strength centrality, considering as a reference interval the so-called metropolitan cities. Metropolitan cities, the technical terms in Italy is città metropolitane. Metropolitan cities are very specific city aggregate and generator of demand in Italy, and they have a specific administrative role in Italy. And considering the network analysis on this, you can see how, in fact, under Naples, there are low value, even if there are not the value different from 0 from degree centrality. The value is quite lower also for strength centrality, while the area of Sicily, even if Sicily is an island and it is connected by only 3 kilometers of the Strait of Messina, the 3 metropolitan cities of Sicily is an island of 4.5 million of people, is completely separated from the HSR system of Italy. While the second case is on a smaller scale, and it is a case study based on the study of all the stations. So the unit is the station, not the metropolitan city, but the single stations, and the single station are placed in the central and southern part of Italy. Of the railway system. We considered not only the full HSR services, but also the HSR trains that go on conventional line, as it is the current state of operations of HSR trains in Italy, considering campus and the RAS, it is the Model 2. And if in the first case we observed the strong differences between the north and south, in this case we can observe a very disaggregated situation between east and west of the network, because even especially between the Tyrrhenian Sea and the Ionian Sea and Adriatic Sea line, this is a functional relationship graph in which you can see how only the city of Rome are connected with both the Tyrrhenian line and Adriatic line, being the other node, the node of Taranto, connected only by one single services from to the Tyrrhenian Sea, and only one single service to the Adriatic Sea. Finally, the third case study, the small one, is a regional case study on the current system of Sicily, because currently the HSR line between the 2 main cities of Sicily is operating, is under construction between Catania and Palermo, and the results show an hugely disconnected values of a huge disconnected systems of connections. So there is a huge room for improvement in Sicily in terms of train connection, especially if we consider the difference between a train and bus. Because in this research we compared the results in terms of strength centrality, considering railway services and considering the public interurban public transport services on street. So going into the discussion, we made also a what if scenario hypothesizing or other new lines, considering, for example, are currently a time travel threshold for 3 hours. Consider this travel time thresholds. There are 2 metropolitan cities of the south of Italy, Bari and Reggio Calabria, Bari in Apulia and Reggio Calabria in Calabria, that are completely disconnected from the main scenario. So the main network. So we considered the what-if approach and hypothesized the major ongoing project on the high-speed rail network, for example, the completion of Salerno-Reggio Calabria, the completion of Naples-Bari, and the completion of the link between Milan and Genoa. And there are several improvements for centrality indicators. Also, which is the point of our work. In general terms, from an infrastructure perspective, the existing line were built following the principles of horizontal and vertical alignment. But from a service perspective, connections are significantly reduced where there are high-speed systems. Also, the free territorial dimension that we analyzed showed a very a structural weakness in the current network in southern Italy that need some improvement. So, in terms of lean contribution, this work contributed in the lean approach in HSR programming in 2 different points. The definition of the infrastructure lean criteria.
I cannot hear you, Antonio.
Sorry?
We hear.
You can hear me?
Yes, we very clear.
Okay. So, okay, we can go to the conclusions quickly. And these 2 points, the definition of infrastructural lean criteria and the extension of lean principles to service programming. So we are going from a lean paradigm that is based essentially on a mono-criteria paradigm to a multi-criteria evaluation approach. In general terms, this proposed approach enables the identification of inefficiencies and missing links, considering underserved nodes, temporal disconnection, and strategic links. And also, future research will have to consider both the lean and agile components, so taking into account more directly the demand contribution. And also this contribution lies in the interpretation of this finding through a lean perspective. So, thank you for the attention.
Thank you for your presentation, of course. We have questions. Professor Mussolino? Yeah. Yes, sorry. I don't know Italian.
Would you hear me?
Yes.
Yes, Professor Mussolino, we can hear you.
We hear you. You don't hear us. Okay. If Professor Mussolini don't have questions, I will put you. How you see the future of the high-speed network in Sicily? Because Sicily have a special, I would say, relief. Is something particular. How we see the future of high-speed rail network?
Thank you, Professor. This is a quite interesting point because the so-called HSR line between Catania and Palermo is under construction, was under construction since 2021, if I remember well, more or less last 5 years. Several sections of the railways have been closed for different period. But I think that at the moment, the declared work, the declared speed is just very quite low compared to the HSR standard, because we are considering that for the completion we are talking of about 1 hour and 45 when will be at complete regime the new railway. In the most optimistic way, we were talking of 1 hour and 45 minutes for approximately 240 kilometers of road. So it's a speed less relevant, very low. It's lower compared to the HSR, the so-called high speed. It will be a good conventional line, and it will reach the average speed of the railway of the train that currently go in other regions of Italy that are not so developed, that share a similar development of Sicily. And at the same time, in order to complete the answer, I don't see another HSR line outside the Catania-Palermo, because I think that Catania-Palermo is the most important origin destination pairs, a couple of nodes in the network. So I don't know if there will be a chance for other lines apart from this.
Okay, you have a lot of details because you live there. And now, Professor Mussolino, you want to put a questions?
And it's not a question, it's just a comment. You saw in this session two components of the large paradigm. You saw the presentation about the lean component by Antonio Russo and Corrado Rindone. The presentation about the green component by Domenico Sgro and other authors. And this morning, there was the presentation of Maria Luisa Moschella during the part 1 of the session about the agile component related to the demand. So these even if they were presented separately, they are part of this research, or part of a great research project that was carried out in Italy in the last three years, financed by the Next Generation EU funds. And where the large paradigm was hypothesized at methodological level, and also we have validated it, some components. Also the resilient components is on validation is ongoing. We validated this large paradigm in a real context, such as the one relating the high speed line in the south of Italy. Thank you.
Thank you for your comments. This session we have a very good presentation.
There is Professor Russo.
Yes, Professor Russo.
Just a consideration, because the consideration of Professor Mussolino is very interesting, and I would like just to recall the session of this morning, where the problem of high-speed rail in Romanian country has been presented by different doctors. And I think that just to consider for the chair of our session, just to consider the possibility to discuss about the possibility to introduce the same research, the same type of research that developed the research group directed by Professor Mussolino in Italy, in different contexts in the Romanian axis, just to consider the different element, the different aspect in a different country as Italy, but I think with very similar economic condition, because we consider the south of Italy in the project, in the PNRR project. And then I think that I think that can be an open way.
Yes.
I don't know. I
I
just
agree. I
suggest
agree.
to
I
our
agree.
chair
There could
to
be similar conditions to apply the large paradigm and verify if there could be which could be the commonalities and difference. There could be a good it's a good idea to as follow up of our project if the colleagues from Romania would agree to this proposal. From my side, I am available.
Yes, of course. So we can continue our discussion to gala dinner, but you are not
Okay,
here. Maybe
Yeah.
next
Yeah.
time we'll come.
we can.
We can exchange password. We can exchange address, email, and then we can discuss by email or in call section. I think Professor Mussolino can give indication.
Yes.
Or Professor Rindone that just a moment appear.
We are open to any collaboration, and at any time we are happy to see a group of transport engineers who discuss, have problems, and also have solutions. Thank you for participation. See
Thank you.
next occasion. Have a nice day.
Bye. Bye.
Goodbye. Goodbye.
Goodbye.
Ciao.
Bye. Bye.
Bye bye.
I think you are the speaker.
Yes, I will.
Do 3 presentations,
Yes.
right?
It's good.
So we can check if you do all 3 together or you
Whatever
prefer.
you want. For me, it's okay.
I would like to check let me check on the GC room if the 2 other authors are ready. Check. Fabrizio is here. Let's see. The other one is. Yeah. So we can do a small test. Fabrício Figueiras, are you here? Can you hear us? Or Paulo Rosato?
Hello there, I'm here.
Oh, thank you very much. We are hearing you. Good, good. So, since you are here, we'll try to follow the presentation on the schedule. So our speaker here can rest between the presentations. So for the first presentation related to the LLMs, I will ask the author to come to the stage and to start the presentation.
Right. Good afternoon, everybody. Can you all hear me? The guys on the call? I think so, right?
Yeah.
So we can get started. I am Jean, and I will present here the work of one of the main authors of this paper is Ramon. He's a PhD candidate in Brazil. And basically, this is a systematic review about LLM-based applications for healthcare. Okay, so basically, you don't need to be a specialist, right, to get to know that we have a lot of applications today related to LLMs, right? So this is growing among different kinds of applications, different kinds of systems, and specifically healthcare, right? So as you can see, a really quick context, we have no publications related to LLMs in healthcare, for example, until 2022. But now, 2025, last year, we have more than 3,000 publications, right? So this is growing fast. About healthcare applications, we have two topics that I would like to talk a little bit, which is the promise that we have on that and the complexity associated to that as well. So the promise is we would have clinical documentations, EHR summarization, risk prediction, decision support, patient interaction. All of this would be enabled using LLMs, right? But to get to this stage, you have a lot of complexity associated as well. So strict requirements. We have to guarantee privacy, reliability, regulatory compliance as well. And also, LLMs are not perfect, right? They can introduce probabilistic behavior, hallucination risks, and integration complexity as well. So we have a gap. This is the main idea here. We have a knowledge gap, how to proper apply LLMs in healthcare applications. So the goal of this paper is systematically map LLM-based healthcare applications, properties, architecture, and the development challenge that we may face once we get into this, right? So this is the main idea. Oops. It's not going to the next one, right? Technical issues. Thank you. Maybe it was me. Okay, thank you. So to proceed with this research methodology, basically we have 3 research questions, right? And they are, what are the main properties or characteristics of LLM-based applications in healthcare? The main points that we need to know. What architectures, patterns, and styles are used in healthcare LLM applications? and what are the main development challenges in this domain. So basically, these three are the main research questions that we have here that want to clarify, right? Search strategy, our search string, and our criteria to have those studies, right? English language studies describe LLM applications in healthcare, this specifically, and excluded ones, duplicates, no full text, no abstract, off topic, or no healthcare LLMs. As I said, we have this search string, and basically we have three main phases to that. So phase one, initial retrieval, we have more than 3,000 studies returned from Scopus. Second phase, we are looking into the title and the abstract, and basically after that we had 206 studies retained after inclusion. And the last phase, phase three, full text and quality assessment, right? After that we had 40 primary studies selected for analysis. And for as criteria, you use the clear research objectives, research-based contributions, described context, a clear challenge there, and these are our limitations as scored 0, 0.5, and 1 to have this a kind of ranking. Right, for the first question, the applications properties that we have there. So basically they are related to four main types of application, right? Question answering, 19 studies for that, information extraction, basically using NLP, prediction and risk assessment, and conversational assistants, right? Or chatbots or everything like this. A few of those studies had more than one of those type of applications, right? So this is why we have a lot of numbers here. Others that we could classify: summarization, recommendation, educational training, near and clinical assessment as well, were although the types of application that we found out. And basically the top used LLM models of families were the ChatGPT, as expected in some way, OpenAI, present in 26 studies, Llama, which is our open model, 16 studies, Mistral, the Queen as well, and Gemini, and specific versions of the BERT for healthcare applications as well. So again, those models were used more than one in a few of those studies, and basically they are the most relevant that we find out. Second questions, the key requirements, right? The functional requirements for those kind of application. As we said before, process and summarize clinical information, extract clinical entities from unstructured text as well, predict health risk and clinical outcomes from textual data, conversational interaction with patients and professionals as assistants, and personalized health recommendations and coaching. So those are the basically functional requirements that we found out in all of those applications. And also non-functional requirements as well, as most cited: clinical accuracy, response reliability, data privacy and security, hallucination mitigation. This is an important one. Scalability and computational efficiency, and interpretability and explainability as well. This is one of the important ones as well. Architectural patterns. The most important was the RAG, as expected as well. So retrieval augmented generation. Multi-agent architectures, we found out this as well. We normally orchestrator agent using other agents for specific tasks. NLP pipelines and other patterns as multimodal, knowledge, graph integration, and mixture of experts as well. But basically, we have this common line here, right? We have the input of the user, we have a few techniques from prompt engineering, then we do the retrieval, then we use the LLM reasoning to get answer. We need to validate this through guardrails or something like that, and then we have the response that we need for that specific model. So basically, this is the flow, and those are the architectures that we found out. Development challenges as the third question. The first one, the response reliability, right? This is like a must-have. The model cannot hallucination, needs to have a consistent answer. So hallucinations, inconsistency, low accuracy, this needs to be, this is a must-have for all of the applications that we saw. Data quality and availability as well. We need to have data that is meaningful, right? Privacy, ethics, regulatory compliance, this is mandatory as well. Since we are dealing with healthcare applications, we have a lot of privacy data that's that's important too. Computational cost infrastructure, that means we are going to have all of kind of application that use LLMs as model, but of course won't be different here. And clinical reasoning and domain adaptation as the last one. In the end, we found out that we actually have a lot of gaps in this research field, right? And we have a few conclusions to that. The key research gaps that we identified were lack of reference architectures. This is one of the most important because there is no kind of pattern yet to develop those solutions. People focus on the application on the task itself and forget about how to make it available to the final user or how to turn this in a solution. Limited discussion of trade-offs is one point as well that we find out. Low discussions on this. Absence of governance mechanisms and weak EHR integration for interoperability between different kinds of systems related to healthcare solutions. We have three conclusions here. LLMs are being actively applied across diverse healthcare tasks with composite modular architectures. This is one of the points. RAG, and multi-agent pattern dominate, right? As you could see in the second question, RAG and multi-agent pattern were the most used architectural patterns. Few studies address architectural governance as well. Critical challenges: hallucinations, data quality, privacy, cost demand, more than the model improvements alone. So this is really a difficult that we found out. As future work, it's going, of course, to be part of the research of Ramon, his PhD. Propose reference architectures for healthcare LLM systems. Develop architectural strategies for hallucinations and bias mitigation, and validate in a real clinical environments to make sure that all of the functional and non-functional requirements will be present on the system, right? So basically, that's it.
Thank you very much. If anybody has questions or comments, okay, maybe I can do a comment regarding this reference architecture. Do you think it's different for the healthcare domain, or is it the same for another LLM?
There are a few points that make this architecture for healthcare applications a bit different. There is a specific kind of patterns, for example, when it comes about data from healthcare system, the specific patterns for this kind of data, the specific protocols to restrict the access to this data, and all of this needs to be taken into account when you develop a system for healthcare using LLMs, right? So there's a kind of gaps in have this architecture to have the solution as supposed to be. So it's not. Of course, there is a few problems here. There is a few points that they are common, right? If you want to develop a system, it doesn't matter if it's for healthcare. You need to care about hallucinations or how you have your interoperability, reliability of the system. But specifically for healthcare, as far as I know, we have a lot of constraints related to the data. Right?
That was my question. Thank you.
Yeah.
So thank you very much. We can move to our next paper, so we can rest a little bit. So I think the next speaker is available online on Jitsi, right? Paulo? Paulo?
Hello. So I guess it's my turn, right? Let me share my screen. Let's see.
Yes.
I mean,
Good. The screen is here, so please start your presentation.
okay. So, yep. Hello, everybody. Good afternoon. I'm going to present this paper, Software Inspired Specialization for Efficient Satellite Image Time Series Segmentation. And, well, this this is about like satellite image time series are just like sequences of images of satellites that are taking over the same geographic area over time, because satellites have an orbit. They're not just stationary, right? They have the orbit. They revisit every location uh, in a specific period, and they provide rich information for monitoring agricultural activity, vegetation cycles, and land cover changes at large scales. Because well, because they because this kind of activity involves times, right? The growth of a crop or vegetation and this kind of stuff. And this is important for automated crop and automated crop inventory is important for a bunch of stuff. One example is for regulatory agencies, because they need to verify if, so like, if the subsidies are being correctly applied, if their farmers are applying the good practice and they are following the regulations, for example. And currently, in this field, deep learning models, and in particular vision truth-based models, dominate the state of the art for SITS crop-semantic segmentation. And one common problem with this type of applications is quadratic cost of vision transformers. Uh, it's a problem for memory management and and computational cost. And the intention of this work is to reduce the computational cost of semantic segmentation without hurting our prediction performance. So just formally stating the problem is a semantic segmentation problem. We have the sequence. Our input is one image that has temporal dimension, a channel dimension, and spatial dimensions. So it's a temporal extensions over time. The multispectral data, we have RGB plus some infrared channels usually in our satellite images. And we want to produce a map, a single map of segmentation map that indicates which crops were planted in each pixel in this grid, spatial grid. So we try to model the phenology of the crops and to identify separate apart what is soybeans, what is sunflower, for example. And we have some challenges when dealing with it. For example, often we have regular acquisitions and missing data because sometimes some timestamps are dropped because they have huge cloud cover or interference in the signal, and heavy cloud and shadows over often hides and obscures the ground observations, and it's issue we have to face when dealing with this kind of problem. And in this work, we part from a baseline architecture. It's called the exchanger, and the exchanger faces some issues like I'm facing, and they have some key design ideas. First, something that is common when dealing with sets, that is factorizing the architecture. We don't process time and space at the same time. We process time first and space later. So, for example, if have our input size, uh, our input size with the spatial grid, we take each pixel as it was a independent spatial independent temporal time series, and we run our vision transformers and our networks in this independent time series. And later we try to collect spatial information to build the segmentation map. So we have this factor design, temporal first, spatial later. And something that is more unique of the exchanger is this three-stage pipeline, collect, update, distribute. So to avoid quadratic cost, it doesn't run of self-attention. It does what it does. It does first cross-attention with learnable carries, because these learnable carries will define the cost of the computational cost of the network of this block. So it separates the temporal dimensions into groups, and then it processes it globally with a MLP mixer. Those groups are processed by MLP mixer, and later it restores the original input shape by applying a second cross-attention mechanism. And the main changes of this paper is in this three-stage pipeline, focusing on the temporal modeling. So we actually mix two kind of ideas. We mix the idea of the exchanger with the idea of soft mixture of experts. Soft mixture of experts are a bit different from the sparse ones or the original sparse ones. We don't have we don't have actually sparse activations, but we split our data into slots by using weighted averages. And the key idea of this paper is to think the cross attention as a soft router. So we can think of this collect stage or this cross attention stage as doing the same thing, or functionally that having the same function of splitting our temporal dimensions or temporal gaps into groups, in specific groups, in semantic groups, and our MP mixer being your expert, being expert in the middle. So the original exchanger was a single element mixer. We can think about specializing each one for each kind of group slots. And when we think about this analogy, we can also think about replacing the second cross attention by the soft combine, because in soft small we route, we do experts, we run the experts, and then we reuse the routing weights to combine the input again. And this is these ones the main ideas. We interpret our collect stage as a routing. We run all MLP mixes as experts, and then we combine them. We're using the attention logics. So I think it will help make it more clear, the pipeline. So we have our time series of satellite images. We split that into patches. We break the dimension and we have only the temporal gap, the temporal structure. We converted our patches into tokens by a standard MLP. Changes our channel dimension to our hidden dimension, so embedding dimension D. And we do the cross-attention that we split our temporal dimension into G groups, G semantic groups. We have each group, each of the mixer, we have some slots to process, and they will specialize in some timestamps. And at the end, we restore our input shape using a math multiplication between the attention logits and the output of the experts. And this gray area is the main temporal encoder. And after we do the temporal encoding, we have the second part of the network. That is, first we collapse the temporal dimension by simply using a mean, and then we have a spatial encoder. And the spatial encoder These are stuff. The way we do the temporal encoding is to be able to use, in principle, any semantic imitation, semantic imitation model or as a spatial encoder at the end of the network. Because how we deal with the temporal data, we collapse the temporal data. But mostly the ones used that are UNet and message former exchanger, original exchanger is UNet message former. We use only the UNet. And taking these ideas, we validated our changes in the baseline using mainly two benchmarks. Our primary benchmarks is the PASSIS dataset, is a dataset in France. It's a bit larger data set. It has images of 128 by 108 pixels at 10 meters spatial resolution and have temporal captures between September 2018 to November 2019 being two, and it has 20 classes. We have 18 crop types. We have the background class and the void class. Void class is out of scope and usually is ignored from the official fivefold cross validation. And the past has this fivefold cross validation with the 5 splits, right? And the secondary benchmark is a bit simpler, it's a bit older data set, also from Sentinel-2 satellite, and it has smaller images, one less type of crop, and we use it mainly because it's mainly for assessing generalization of our approach. Because, well, we have our training protocol. A training protocol is somewhat standard. The fastest data set has a pixel set format. It basically destroys it removes the background and takes samples from each area of the same from each that has the same type of crop and make a sample of it. So it's a somewhat linearized, flattens an image, and we use it to pre-train the temporal encoder. This is something you would take from the baseline exchanger approach. And later we use the main classes to fine tune the model end to end, and we use the UNet spatial decoder. Spatial decoder, and we have some data strategy implementation. We train the patches in 32 by 32 crops. It's mainly due to the memory constraints when training the neural network. 128 by 128 usually leads to out of memory errors. And one data augmentation strategy that is common in SITs is randomly dropping some time steps during training. It helps with orbit fits and about optimization. Loss functions are um, somewhat common. We use cross entropy, ignoring the void class. We use optimize at NW, and we have our rate schedule, linear rate schedule. We have a 10% warm up, and I have a polynomial decay. Something important about that is because this spatial cropping technique is a bit different than what our baseline does, and that leads to some different results that I will talk about later. But first, there's the ablation study. The ablation study, we use the past validation, the past data set, and we use the training, we use the split one, training and validation sets to pick our hyperparameters in our neural network. And that makes you hyperparameters is choosing the number of groups and the number of mixes. So in small terms, it would be the number of slots and the number of experts. So we don't have huge gaps in performance, but you have a steady marginal gain when we scale the number of the number of groups, right, from 2 to 16. And based on that, we pick this the 16 the 16 groups and the 4 groups in and try to see what was the effect when we increase the number of experts. And well, the gains are also marginal, but they are somewhat consistent. At least they often increasing the number of experts often is better than using a single one. And this choice of 4 groups or in 16 groups is interesting because it gives us a heavier model and a lighter model because the complexity is or the theoretical complexity is based on mainly on the number of groups. And well, after the ablation, we run the main benchmarks, the passes and MLTCC. So passes is we run the full cross validation and the 5-folds, and MLTCC has single train and test split. And well, we have and in the literature in the exchanger paper, they report the results using the UNet spatial encoded and mask transformer. Uh, and we only use the lighter one, the UNet one. And because our training strategy was different than the original paper, we also report our our training results, our training results for fairness, because well, our training strategy um, led to some MIOU gains, in despite of the architectural changes, and it would not be fair to compare to the original paper without reporting our results in. Uh, so in the end, we don't have high gains in MEO, but they are marginally higher in passes and a bit higher in alpha TCC. But the original intention of reducing the computational cost is more expressive. So we increase the number of parameters in the network, but a number of float point computations actually dropped. And I have some graphs to show that. So we have this scaling of of the number of flip-flops according to the sequence time length, and for the exchanger baseline, and for our model, our changer model with 4-2 configuration and 16 by 8 configuration. So we have this empirical experiment shows the validates the linear complexity, the linear complexity, and it shows that we we can reduce the number of uh, float point operations depending on the sequence time length, without actually hurting the prediction performance. We also have the latency, so this is interesting. Uh, the latency is not theoretical; it depends on the hardware, and our hardware is the NVIDIA 830 GPU. And it's interesting that for a heavier model, it and small sequence lengths, we are almost tied to the original exchanger. But in the scale, we also have gains in latency, and our lighter model have a really lower curve in terms of latency. And similarly, the almost the same percent happens for throughput that reporting samples per second. And well, we have a quick uh, qualitative results. Just one sample that shows the one-time stamp of a patch, and what was the label, and what's the predictions. And the predictions, as the table showed, are very close to one another. But we have some, but you can do that with a lower computational cost. And well, the conclusions in future work is I think we did successfully integrate some optimal concepts into the exchanger pipeline. We did have some gains and computational gains in not in complexity but in cost, and some practical gains. And in future, we can try to investigate more types of adaptive routing, depending there's some more sophisticated type of routings in mixture of express literature we can explore, and we can test about the scale, the data scale. Our data sets are not they are large, but they are larger data sets, and maybe when we are working with more parameters, a larger data set would benefit these changes in the architectures as well. And well, that was it for today. I open up for questions. I guess that is
very much,
a bit over time, actually.
We're just on time. We have time for a quick question. Thank you for your presentation. So, Paulo, if you can, please still be around on the room, and if someone wants to make a question, you can chat to you. But then we can move to the next presentation to keep the schedule. So I will ask again Ramon to come, and so we have the second presentation.
Thank you.
Thank you very much, Paul.
Which one is it?
The second one.
Okay.
Okay, everybody, so I'm here again, and now I'm going to present another systematic review, but now in another field of research, which is the textile industry. So basically, it's a systematic review of PPCP, which stands for Planning, Programming, Control of the Production Models, Artificial Intelligence, and Optimization applied to small-scale textile industry. Okay. Before, this is our work from Gabriel is the main author of this work. He's currently a master degree candidate in Brazil. And let's go. So basically, the motivation for this work is that the textile production is economically relevant and highly dependent on small and medium-sized enterprises. I know that there are a few folks from Brazil here on the call, and this is really common in Brazil, mainly in northeast of Brazil. We have a lot of small and medium-sized enterprise for clothing and manufacturing. So this is really have a high demand there. These companies face volatile demand, limited resource, and pressure to digitalize production planning. This is one problem that they have right now. Most part of them, at least the ones that I'm aware of, basically, they still use Excel files to proceed with the PPCP. Production planning, scheduling, and control, or as I said, planning, programming, control, and control of the production, can translate market demand into operational decisions. And the idea here is to identify opportunity through this research, right? The research opportunity is to combine the PPCP with artificial intelligence strategies, maybe optimization strategies for those specific kind of textile industry which are really particular, right? So, the research gap, publications on PPCP have grown substantially between 2000 and 2024. This is one thing that we found out. Publications combine PPCP and AI, or maybe optimization based on AI strategies, have not followed the same growth. This is a specific point. Previous reviews often focus on specific textile technologies, not for those ones. This review starts from agnostic perspective and maps which PPCP, AI, and optimization approaches can be relevant in this scenario. So the primary question, or the main research question that we have here is, what are the most effective models and techniques and models, AI models or techniques, maybe optimization techniques. It doesn't necessarily involve AI somehow, but the problem is here is to establish the PPCP strategy, so workload balancing in textile, small and medium enterprises, or similar companies as well, right? Please. Beyond that, here we have the secondary questions of research as well. As I said, we have the primary one, but we have a lot of points that we take into account in our research as well. So, what are the best algorithms for optimization to use in a PPCP scenario, right? How is the use of deep learning strategies and genetic algorithm and LLMs for scheduling of the production as well? Strategies for data entry and automation in this process. Forecasting models for volatile textile demand, factors affecting production line balancing, application scenarios used in the reviewed models. So those are a lot of secondary questions that we thought that would be important to consider as well in this review. Thank you. So basically the methodology is a systematic literature review with the inclusion criteria, exclusion as well. And those three were our databases to proceed with the systematic review: Scopus, IEEE Explorer, ICCSA Digital, Web of Science, Science Directly, of course, the main ones. And the studies that we considered were published from 2019 until now. We started with 379 papers, right? And the first phase were, let's look into the titles and abstracts to see how related they are with the study. And second phase, full text reading. And basically, by the final selection, we had remaining 23 studies that were based in our systematic review. As I said, 23 studies. The most selected studies were published between 2021 and 2023. No 2019 studies were selected after applying the criteria, so we got the most recent ones. And basically, the one important evidence that we found out here is that each study tends to propose a different model or a different approach, which makes different to compare them, right? To compare, to make a comparison between them as well. Most effective approach, thinking about strategies for optimization, we had the Lean Six Sigma with discrete event simulation, hybrid genetic algorithms for resource allocation, dynamic TAKT time. I'm not sure if you are familiar with this word, but it's basically the time that's necessary since you open a production order. So there is a need for this for a specific kind of product until the moment that you actually deliver that product to the customer. So the time since the product is requested until the time that the product is actually delivered. So basically this is what means TAKT time. It was a concept introduction by Toyota, by the way. For real-time production pace adjustment, so I can maybe adjust this in real time, and digital twins, mainly for simulations of the production line associated to monitoring as well. So the pattern that we found out is hybrid and adaptive approaches are better suited to variability, resource constraints, and changing demand. So as you can see, right, different kinds of solution for different topics. Here we have a few results from how those strategies can optimize the PPCP process, right? The Lean Six Sigma reduced process time by 5%. This was a specific small and medium enterprise case. Hybrid genetic algorithm with table research achieved at least 92% optimized based on a human resource utilization. Competing algorithms in that comparison did not exceed 80% utilization. Intelligent machine monitoring system increased productivity by 55% compared with conventional ERP. And the MCTS, Monte Carlo research, achieved 0 to 1% optimality gap with lower computational time than the value iteration. So a lot of improvements, a few of them are really good improvement, a few of them a small improvement, but still improvement with different techniques. Okay. Relating to AI specifically, before we were looking to the optimization strategies, not necessarily related to AI itself. Now, what we found out related to AI, artificial neural networks and combined with genetic algorithms were used for simulation optimization in industrial context. This is one of the points, this combination. Deep learning as well, again, together with genetic algorithms appear as a promising tool, mainly for optimization, but directly evidence for job shop scheduling is limited. Only one selected study explicitly mentions job shop scheduling, and no selected study explicitly applies large language models to PPCP. This is one of the points that we highlight as one of the main gaps, right? So we couldn't find any LLMs-based study or application itself in the PPCP context for this kind of enterprises. Related to automation in forecasting, I don't know if you remember, but those were 2 points in the secondary questions. Automation and forecasting, what we found out were that ERP and MES data import, those are specific kind of systems in this context, cloud-based APS systems, digital twins for simulation, as I said before, and a few techniques and devices for shop floor control. For forecasting of the production, normally non-stationary and stochastic demand models, MDP and MCTS, as I said, for dynamic demand and lead times, and artificial neural networks, again, integrated with GA for simulation of the optimization flow. A few factors affecting line balancing. This is one of the points that we considered in the secondary questions as well, that we thought that would be important to bring. In terms of operational, we had the demand variability, operations sequencing, setup times, labor variability, and product mix and volume change. So this is all of the points that we found out in operational perspective of view. In a structural perspective of view, we have inadequate layouts, balanced process capacity, bottlenecks and buffers, finite machine capacity, and digital maturity and integration as structural in this context of enterprises, right? Small and mediums. A few implications that we thought that would be important to highlight here as well. Basically, they were the PPCP for textile. Small and medium enterprise should move beyond monolithic solutions, as it has been done these days. Modern systems can combine forecasting, scheduling, allocation, monitoring, and simulation models. Hybrid models, as we could find a few of them, can help optimize staff allocation, reduce idle time, and support demand-aware planning. And modular multimodal PPCP systems are a promising direction for practical adoption. A few limitations of this review as well. Few studies met all criteria for practical PPCP applications in small and medium enterprise. So we had a kind of lack of specific studies and data and real scenario for the context that we would like to check. Technologies are difficult to compare because each paper proposes different models, so we could highlight the different approaches, different techniques, but not compare, make a comparison between them. Some studies assume dynamic factors are constant, so this could be a problem, specifically in this kind of scenario, which is really volatile. Other limitations include low flexibility, high cost, and significant operational time, which is really a block for this specific scenario where we have small and medium enterprises. Conclusions that we have here and proposals for future work. One of the most used strategies that we found was the combination of a genetic algorithm with another model, with another strategy. So this is one that we bring here, GA combined with taboo search or maybe artificial neural network in a load balancing and resource optimization. One of the approaches that we found out that can improve the optimization of the process as well is the Lean Six Sigma. It's effective for identifying waste and bottlenecks. The Monte Carlo research is promising for load balancing and demand forecasting as well. No selected study explicitly applies LLMs to PPCP. So basically the future work here that Gabriel and our research group will proceed is to develop a PPCP system for this textile, small and medium enterprises using optimized intelligent models and natural language interaction where we can bring the power of LLMs to help a specific one of the points that we saw, operational or structural as well. That's it.
Thank you very much. So we have a study to improve the manufacturing of textiles in Brazil.
Yes.
We also have a lot of textile companies here in the north, in the Ave Valley. I think bigger ones.
Right. Yeah, I think so as well. That's like very common in northeast of Brazil. We have partnerships with a few of them to get real data. Actually, the next work that I will present is one that we are using real data scenarios to build up associated to this specific kind of companies. They have a lot of potential to be improved.
Yes, our university has only 50 years. It's a recent university in a certain sense, but started exactly with the textile engineering. And still today we have also have courses related to the textile, because the textile industry was the biggest one here in the north. So I don't know if you have questions, comments from the other participants. Let's move, and thank you very much.
Thank you again.
Take your seat for a while. So we can move on to the next presentation. I think it's Fabrizio, who will do the next presentation.
Yeah, it's me.
Hi, Fabrizio.
You can see me. You can listen me.
Yes, it's a little bit lower. If you can.
Okay, I will speak louder. Okay.
It's okay. It's okay. It's okay.
Okay, my name is Fabrizio. I'm here to presentation our work titled Impact of Anatomical Position Marks on Breast Cancer Detection Thermography. This research was conducted at the Federal University of Juiz de Fora in Brazil, in collaboration with my colleagues João Pilar, Luisa Nascimento, and our advisors, Professor Eder Bernardino and Saulo Vilela. Oops. And here's the outline. I will start to take a brief description for breast cancer, the problem breast cancer, and why thermography is promising. Then I will present our data set and our methodology. And next, I will discuss our unexpected results and our hypotheses and results and the future work. Uh, let's start with breast cancer problem. Globally, in 2022, there were 2.3 million new cases and 607,000 deaths worldwide about the breast cancer. And by the 2050, project estimated 3.2 million new cases and 1.1 million deaths annually. In Brazil, the situation is equally concerning, with an estimate of 73,000 new cases per year between 2023 and 2025. Today, breast cancer is mainly detected using mammography, ultrasound, and MRI. But these methods have some limits, like cost, access, discomfort, and other things. So, why did we choose thermography? First, it's a non-invasive method, require no physical contact or breast compaction. Second, it is don't use ionizing radiation like mammography. And finally, it has a low operation cost, make an attractive resource limit contest, such as a public health program in the developed countries like Brazil. Uh, for all these factors, thermography is an attractive option. But how it works, how we can learn about the thermal image? Sorry. The answer is by the biology of tumors. They can be associated with increased vascularization and metabolic changes that generate a distinct thermal patterns that can be captured by infrared cams. And the challenge is, if you see in this image, it's not easy to identify a health or non-health case. So in this case, bring us to our computational support. I put here a flowchart to explain a little about this. First, we have our image. We put our image in the model. Before the model, we have a pre-processing like resizing, normaling, augmentation, and the model learn to how to see these little patterns in the image, in this difference in the image, and give us our output, if it's a health case or a non-health case. Okay. Uh, let's talk about our materials. We use a database called Database for Methodology Research. We call Visual Lab DMR. It's more easy for us. This is a public available dataset that's widely used in the literature, and the data consists of frontal, left and right 45 degrees, and the left and right 90 degrees views. And also, the image has a resolution of 1640 by 1480 pixels and came in grayscale for our work. And here are a table with a distribution by angle. As you can see, each angle has a balanced distribution between health and non-health cases. And for our study, we choose only the frontal angle to ensure a clear analysis for our case. Okay, let's talk about the classification setup, what the pipeline we use. First, we put all of these frontal thermal images in our model, and we pre-processing before this model to resize it to 224 by 224 pixels for our model can see this image in this size. We use augmentation, zoom, flip, so we can have more data to work with. And for our CNN base, we use a VGG60. It's a visual geometric group for binary classification. And this binary is a health or non-health case, and you bring to us these answers. And for this first study, we use a model with a 5-fold cross-validation to define our results and see clearly what's going with it, with this model of this study. Okay, originally, we start with original images. We don't make any changes and put this image to train in our model. And we use too the segmented images. The segmented was generated by a tool called IOLO. It's you only look once to isolate the breast region and avoid some other information. Initially, our expectation was removing the background. We will help the model focus on the relevant part and give better results in our study. But it comes an unexpected result for us. As you can see in the tables, the full image got more expressive accuracy than segmented images. This is quite surprising because we expect, as I said, we expect that the segmentation is improving the performance by the model. So let us to ask, what was removing the segmentation? What we need to learn about it? Okay, if we do a checklist, we remove a background, we remove external breast regions, and we remove this anatomic position mark we call as a tag. This tag is a small square placed on the patient's chest during the image acquisition. It might be contain relevant information that helps the model make the decision. This when we start have this question, we try to look a tool called heat map. Heat map it's a tool to show us where the model look when they try to find this difference between the images and the difference between these patterns. And as you can see in the image, when we look at the heat map, it seems the model focus on the marker region to identify the cases correctly. And with this in mind, we have a hypothesis. So the tag influence in the results. So let's try to create a 7 controlled versions of our initial data set to identify which it's better for the model to learn. So first we have our original image. We did not make any changes. We have a segmented image without marker. We have segmented plus marker. We can overlay the marker with the segmented image. And without marker, we completely remove the marker. Okay. We move the marker outside the boundaries of the patients. As you can see here in the image, and we fix the marker by 28 by 28 pixels. And the last one, we fix the temperature inside the marker to evaluate this case. This allows us to systematically evaluate the contribution of these markers in our study. Okay. To compare these 7 configurations, we follow a statistical protocol. We perform 30 independent executions for each configuration using the same experimental setup as I described earlier. Then, with these numbers, with these results, we apply the Shapiro-Wilk test to check the normality for these results. We apply ANOVA one way on ANOVA test to see if there's significant difference between one configuration and another. And finally, the James-Howell post-hoc test to identify which specific configuration difference from the other. Is to compare one in order. So, the most important thing now is the Shapiro-Wilk test confirmed the normality, so we can proceed with other parametric tests. And with this other parametric test, we can see here in this table marker moved marker, segmented configuration, and without marker show a signal difference between the original configuration. In the other hand, fixed temperature and fixed size not show significant difference from the original. This suggests us temperature and the size not make a bigger impact on the model. So, bring us to our conclusion. What did you learn with this model, with this study? The marker, it's just not a noise. It's how actually helps the model contain some information. The position of the marker matters more than the size and the temperature, as you see in this table. Position matter more than size and temperature. The key point is the marker gives a spatial context to helps model to be more assertive in this output, in these answers for us. And for the limitation and futurology of this study, of course, we use only one architecture. We use a VGG based, and we only use one data set. It's a visual lab. And we will only use the frontal angle. We have more to improve on this contest, but it's important to make a point. The market in this visual lab, a worldwide database, use imports impact on the results. So we can learn about the tag and impact the results of the classification. And for the future work, we have to test in other data set to verify if the effects hold, and use other architectures like MesNet or YOLO classification to improve this information for us. And as my actual personal research, I try to use this experimentation for other angles inside the database of the Visual Lab to confirm our analysis. And That's it. Thank you for your attention. My mail is in the screen, and I'm happy to take any questions now.
Thank you, Fabrizio. Thank you, Fabrizio, for your presentation and the results you showed to us. I don't know if there are any questions.
Actually, I have a curiosity.
Yes.
Fabrizio, can you hear me?
Yes, I hear.
Fabrizio, I just would like to know if you already know what kind of clinical data you are expecting to use in the future work. You mentioned that beyond the images, right? You expect to use clinical data, maybe to, of course, to try to improve the performance of the model. I just would like to know which kind of clinical data you are expecting to use.
Okay. For now, I'm using the idea of other angles, but this data set, Visual Lab, have other characters like ages. How can I do? If the patient have some disease like diabetes, and in my mind it's difficult because I work with a lot of information, but that kind of information, for example, the age of the patient, and we can search for the age between, for example, 20 and 30 years. No, it's a personal information that Visual Lab has to help us. But if I have to work on it, we need to pay more attention which information we need. But this data set provide to us.
Right, Professor. Thank you. That's good. I think that's a good model perspective for this kind of work. It'll be really interesting. Yeah.
Thank you. Is that a question? I didn't listen well.
No.
Okay.
Just noise on the room. But thank you, Fabrizio.
Thank you.
We'll go to do our last presentation by our super
Right. I guess you guys are tired from me, right?
We are going back to the textiles.
Yes. Now we have not a systematic review, but application.
In each part of Brazil, this is
Northeast of Brazil. Cities of Natal, João Pessoa, Recife, mainly northeast of Brazil.
That's this one? Yeah.
That's it. So now we don't have a systematic review, right? Actually, we have a proposal here. We are focused on textile industry again, but in this specific context. Now one more kind of enterprise, which is the micro, small, and medium enterprise. So micro, maybe between 3 or 5 people here for clothing manufacturing. And in this solution, we have implemented an orchestrated multi-agent system for PPCP, planning, programming, control of the production in the textile micro, small, and medium enterprises, a prompt engineering approach, right? Again, our work which the main author is Gabriel from our research group. So the motivation for this work now is that a little bit from the systematic review as well, right? So the textile, micro, small, and medium enterprises operate on a volatile demand, short product life cycle. So it's really fast how it changes, and the pressure for cost reduction, mainly in this specific ecosystem, right? Conventional PPCP systems, as you probably know, there are a lot of PPCP systems, but the most relevant ones in the market, they struggle with real-time rescheduling and finite resource coordination for this context, right? They operate well considering big companies or a big textile industry, but for this specific scenario, they don't. So industry 4.0 solutions are often difficult for this specific kind of enterprise. Limited technical skills, mainly the budget, right? This is the biggest problem here, and the infrastructure as well. So they suffer from those specific kind of points to use solutions that are already there in the market. So the goal here is to have a solution that can support dynamic PPCP decisions through an orchestrated LLM-based multi-agent system for this kind of enterprises. Okay? To state the problem precisely, right, the PPCP requires sequencing work orders. This is the very first point of the PPCP, right? You need to know what you are going to do and the order that you are going to do. The coordinating shop floor resource as well, because if we need to produce here a specific kind of cloth in a specific color, you need the resource to do it. And reacting to operational disruptions. This is really common as well in this specific kind of enterprise, right? As you probably know, the fashion industry, right, increases product variety and decreases product life cycle. So it changes fast, right? You need to adapt to this. Nowadays, the companies that work in this scenario, at least the ones that we have partnership, mainly they use, or maybe a Excel file, maybe even ERP systems, but they are not automated. So all of the process to start a new order, to coordinate resources in the shop floor, they are all manual. So the user needs to actually manually input data into the system. Manual data entry and static planning make PPCP slow and error prone, right? It's really hard to keep this coordination, the operational disruptions that could may have in the process, and the sequence work orders in an optimal way with this manual process from the very beginning. Monolith, and as the last point, as I stated, problem, we could take the data or take those blocking points in the company and try to use a monolithic LLM solution to do that. But we still would have a few problems that we need to take into account, which is can introduce hallucinations, latency, and non-deterministic output. So how we can guarantee that the output of the LLM system will be useful and will be useful, and how this output won't have those problems, right? So this is a research gap, and basically from the literature we have saw, as we presented in the last work, right? The systematic review that we did on that. We have a lot of hybrid models, hybrid approaches, mainly with genetic algorithm, promising for workload balances, digital twins, ERP integrations with devices based on RFID, Lean Six Sigma for support automation, simulation optimization for stochastic demand, but we didn't find any large language model based solution applied to this specific ecosystem, right? So this is what we are planning to do here. The contribution that we need to propose, that we want to propose through this work, is a modular PPCP system based on orchestrator work pattern, right? Orchestrator work pattern is basically a kind of architecturally LLM-based solution where your first agent to receive the input of the user is an orchestrator. So basically, this agent will decide the other agents that will actually do the job, will do what the user is requesting, right? LLM reasoning is used for semantic interpretation and natural language recommendations. So this can be way easier to the user, to the people inside the enterprise. So we don't need to input all of the informations manually, right? Deterministic modules handle numerical calculations and operational metrics. This is one of the points that we would like to highlight too. Normally, when we talk about a monolith LLM system, the LLM does everything, right? But here we know that there is specific tasks that could be just a deterministic module. Doesn't require our LLM to do it. So as a framework to build this orchestrator work pattern, we used LangGraph. So basically the LangGraph coordinates specialized agents through the computational graph. And associated to those agents, we have the deterministic modules, which are, as example, tools, right? Imagine a specific function that you can call it, and we will have your output. So if you call this deterministic module and you, as source of information, you provide the same input, you will have the same output, right? The system process unstructured orders, suggests setups, reallocates operators, and generates reports. So thus the process from the very, very beginning, since unstructured orders and until the end of the process where the company itself can see statistics, can see data from his production line. Here a little bit of the stack that we have used to build the solution. So basically in terms of technologies, fast API for external access, so to make it available. LangChain as the framework for the LLM and tool coordination. LangGraph as well for the agents for state and execution of the flow. Postgres as our database and for our structured production data, and MongoDB for the unstructured production logs, right? Thinking in a NoSQL database. Interaction flow, so this is how it's going to operate. So in the very beginning, a natural language query starts the workflow, so the user can interact with the system using natural language. This query will be processed by the orchestrator. So the orchestrator agent interprets the user intent based on the query. Knowing the intent of the user, the orchestrator can consume a specific agent that will do the job, right? The conditional edges activate the specialized workflow. This is a specific agent that will do what is required based on the intent. Responses are standardized before returning to the API. So I need to check those responses before I send them to the final user, right? We have to apply a few techniques, for example, as guardrails, to make sure that the response is it's good. Okay.
Okay.
Thank you. So for this application, basically we have 6 agents, right? We have the orchestrator agent as the first one to receive the query of the user and to process the intent of the user. And after the orchestrator agent, we have more 5 agents to do the job, right? Based on what's necessary to do. So the production order registration, this extracts operations and standard times from the PDF sheets that were provided by the user in the first query. We have a specific one to do that. Setup suggestion allocates operators using historical performance. So this is, of course, based on the query, based on the data provided. It will check the historical data that I have, and based on the performance, it will allocate operators to do the job. Also, we have another one for operator reallocation. If we need to change, if we need to adapt to any situation, he acts to the bottlenecks and workload changes. Operation report turns shop floor logs into efficient indicators. So normally, today, they don't have this visibility of how is their production line and how they are delivering a product and how many days, for example, or how many how much time it's necessary to produce a specific kind of code, for example. And the idea here is to give him this visibility. Response formatter, this is another specific agent as well for standardized outputs across workflows, right? As I said, we need to always care about the response of each one of those agents. This is the very, very beginning of the solution. So basically, the people from the enterprise will provide a PDF, for example. It can be another kind of file, but normally it's going to be a PDF, and we use it a PDF for this example, with the production order and with a few informations that are required to start the production line. So the system first attempts to native text extraction. We need to know what's there in the PDF using native text extraction. If the document is scanned, and normally the document is scanned, it's not a digital one, so we need to use computer vision techniques to understand what's there. So normally pages are rendered at high resolution and pre-processed with OpenCV. To do that, we are using the GPT-4 Mini as the model that's going to extract the operations from the technical specifications in the document. And we use here a few libraries from Python, Pythonic, and a few guard use strategies to validate the structured output before send this to the user, right? So this is first point. Okay, actually, we thought that would be interesting to really validate this prompt optimization strategy by comparing with an initial approach where we have a monolith LLM prompt. So it's not an orchestrated agent. We don't have those 6 agents. We have only one to do all the job, right? And here our refined approach where we have those 6 agents, a few of them are deterministic models to do specific kind of functions that don't normally this kind of operation doesn't require a reasoning behind it, right? So basically in the monolith LLM prompt, the strategic analysis and the mathematical calculations in the same call, so everything that needs to be. Of course, we will have higher cognitive load, right? More time for reasoning operations because everything is done in the same model. And occasional arithmetic hallucinations. This is one of the problems that we got in this strategy. In the refined approach, where we have the determinist calculators, this won't happen, right? We don't have the occasional arithmetic hallucinations because when we have to process this specific kind of arithmetic related to the production line and related to the work orders flow, we can call specific functions or tools that will do this precisely. Numerical results are injected into the LLM prompt after this calculation, and the LLM focuses on semantic interpretation and adaptive strategy, which is a way better in this approach than in the first one. But of course, we need to compare. And this is basically the numbers that we have. So basically, for all of the metrics that we considered here, we have improved result in the decoupled strategy or in the orchestrator, in the orchestrated agent. The latency, the token consumption, which is really important, maybe considering this specific kind of enterprise, right? Estimated costed for the same model, the GPT-4 Mini. This is from March, I think. We already have tested with the Gemini Flash as well, and we could get this even lower. Calculation accuracy. Here we have 100% because, as I said, he's determinist, right? If you give the same inputs, we have the same outputs. So it doesn't change, as you can have this hallucination here in the monolithic strategy that the calculation accuracy may vary. Numerical reproducibility, one, because it won't change as well. So overall, the highlights that we bring here is that we have a reduced latency by 79% and token usage by 75%, which are the most critical points. Again, thinking about this specific ecosystem, right? You don't need, you want so high, not having any latency, and try to reduce the cost as much as possible. The case of study that we have here to validate the proposal was using a simulated shop floor scenario, but with real textile data, right? So we got data from one of those parties that we have in this textile industry. And of course, we simulated a shop floor scenario, but with real data to guarantee that could be applied in a real plant in future. Inputs included unstructured production orders in PDF, as I said before, collaborators' histories, and smart device logs. So those were the main source of data that we had to proceed with this scenario. Each station logs production events in real time. The example production order contained 12 operations across 4 production phases. So basically, I have 4 in this specific part that we could use the real data. The production phase, we have 4 production phases and 12 operations in total. The manual registration would require, as I said before, if the company needs to do that, needs to proceed with, for example, those 12 operations in the way that they do right now, they need to proceed with a manual registration of the information, right? The workflow and the operators and a few logs that they need to check to use. So the manual registration would require 7 plus 3 times n fields, right? And n here is the number of operations. So this means 43 manual fields only to start the process, right? Production order registration. This is the first step, the first phase of the solution. So the technical specification sheet, which is the PDF file provided and was provided for one of the partners, was a scanned file. So we already had to use the OpenCV to identify the information that were there. The production order registration agent was the first one to be activated to proceed with the computer vision. As I said, the model that we are using is the GPT-4 Mini, identified the vertical hierarchy of sewing operations by phase, and the system successfully extracted the 12 operations from the 4 production phase. So based on the PDF, based on the technical specification, our model could successfully extract the 12 expected operations and the 4 productions phase as well. Human in the loop validation shifts the manager from manual entry, he doesn't need to enter those 43 lines, to data check. Now, the user there in the company would need only to check if that's right, and we are good to go. Setup suggestions. So this after the identification of the operations that would be required and the phase that would be required as well, we are going to the second stage of the system, which is the setup suggestion. The setup suggestion agent, which is another agent that we have, allocates operators based on operation, needs, and collaborator history. So we need operators to do the job, right? And he is going to allocate specific operators based on what's needed and in the collaborator history as well. And basically they have this kind of information. In the experiments, 7 operators were available for those operations. The phase 1 operations found matching historical competencies. Later phases used a fallback policy when no specified history was available. This is really common as well if they don't have this kind of information. The deterministic calculator estimated 4.43 hours to produce 100 items. And basically we found out that the bottleneck here was the attached pockets at 1.85 minutes for each one, right? So a really consuming point here, thinking about the total that was estimated. Operator reallocation, of course, the changes can happen and adjustments need to be done. So the operator reallocation agent reacts to those bottlenecks that may be found and early task completion, right? So a simulated bottleneck event required moving operator from joint shoulder. So we did that to check how the agent would work in this scenario. Candidate destinations included hemming, double stitch, and closed side seam, for example. So the idea here is just to change the task and see how the agent reacts. When no prior operator experience existed, a deterministic fallback selected the best available option. So this is one thing that we do as well. If we don't have the data to determine the most suitable one, the LLM generated a plain language technical explanation for the production manager to see and to check if I have the resource, I have the operators, I have, for example, the time to have all of the order done. So this is after the operator reallocation. Operation report, as I said, we have all of those data. The operation report agent compares MongoDB production logs and unstructured data with the Postgres standard times. It computes operator efficiency. So now I have a visibility of how my operators are working. I don't have it before. The production order performance, I can check how is the performance of my production line. The system detected unusual efficiency values caused by outdated standard times. We can check that too. Reports help managers compare operations, identify improvements, and review technical standards. Basically, we have now visibility to take actions considering data. We don't have this right now. So the pipeline covers the full cycle: document input, planning, adjustment, and the strategic reporting. The main findings here is that the multi-agent orchestration reduced prompt complexity and improved reliability, right? You only need to input the PDF file with the technical specification. We don't need to talk with the model there, right? Separating the deterministic calculations from semantic reason, eliminated our arithmetic hallucinations in tests. This was really good and actually very important as they are deterministic. We want to guarantee that we will have 100% of accuracy in this point. The architecture reduced inference time, as we showed in the results, and token usage as well, which is really important for this specific kind of company, while preserving natural language decision support. So the quality of the solution wasn't a trade-off, right? The case study showed feasibility for production order, digitization, setup planning, operator reallocation, and reporting, the main 4 steps that I showed. And as conclusion and future work, we have the proposed land graph managed multi-agent system, modernized the PPCP for textile, as we show here Of course, we have a simulation, but we use it real data. And the idea is to validate this in a real scenario inside a company, right? Its main innovation is combine LLM semantic inference with deterministic calculation. This was a really good point, as we could guarantee no hallucinations in arithmetic tasks. The system offers a practical path for bringing Industry 4.0 decision support to smaller enterprises. This is really important. This is the context that we are working right now. And as the future work, the idea is to deploy this architecture in a real manufacturing settings and evaluate under a live shop floor conditions. This is the step that actually we are working on this right now. We are evaluating those results at this moment down in Brazil. That's it.
Thank you very much. And thank you for sharing your proposal. And the findings you already discovered. Is there any questions on the speaker? I think we can talk later.
Yes,
I
would love it.
Gala dinner. So I think we'll finish the session. If there are any comments from the remote users, yeah. So thank you once more for your third presentation, and thank you for your assistance. And I invite you to join us at the Gala dinner down there on Bom Jesus later at 7:30. Okay? Thank you very much.
Thank you. Thank you very much.
And thank you to our technician.
Posso fechar a sala?
Não.
Ai não?
Podes-me fazer um favor?
Posso.
Aí no PC tem que instalar um software que se chama, preciso mesmo, que é para logo para projetarmos no jantar, se chamar NDI Tools. NDI Tools. É que se vai primeiro, logo primeiro. Windows.
Engenharia de Sistemas. Mestrado.
Aqui DPS.
Sim.
E fizeste o quê? Uma licenciatura?
Tirei Engenharia Biomédica.
Aqui?
Sim.
E que ramo é que fizeste?
Foi só licenciatura.
Só fizeste a licenciatura?
Sim.
Boa. Depois tu foste ir para a produção?
É. Não gostei muito da Biomédica, afinal. Gostei mais das cadeiras. As cadeiras que eu tinha gostado mais eram as de DPS. Por isso.
Jorge, né?
Jorge.
Dizer, Jorge.
Vemos lá em cima?
Acho que sim. Não sei como é que vai estar os horários, mas acho que sim. Porque tá uma correria aí já hoje.
Não, temos lá jantar, temos surpresa, temos uma surpresa antes.
Ah, é? Eu queria, na verdade, pegar o seu e-mail, porque de repente eu posso mandar um portfólio de algumas coisas que a gente tem no laboratório.
JR. JIR. R de Rocha. Que é Jorge Gustavo Rocha, @ DI, que é Departamento de Informática, .uminho.pt.
Olá.
É sério?
O professor estava a ver, queria fazer aqui alguma coisa. Sim.
Oi, gente, Cássio, nós lá em cima vamos precisar de 3 computadores. Lá em cima? Verdade. Ia fazer aqui um teste. É assim, 3 porquê? Porque este tem um sistema de vídeo num canto. Imagina, uma sala muito comprida, tem logo um sistema de áudio. E então, não é projeção.
Ao DJ?
Ou seja, tem de ser um cabo com as colunas. Depois tem aqui no meio da sala um projetor, está longe dali, e outro projetor que está longe dos outros. Por isso eu ia pôr aquele computador, fazer broadcast de vídeo, e estes a ser repetidores de vídeo ligados aos projetores.
A mesma imagem? A mesma coisa?
É. Ou seja, o que estiver a passar entre o computador dos outros são macaquinhos. E experimentar este NDI tools que nunca usei, mas basicamente um computador projeta é como se fosse tipo uma.
Sim, e os outros fazem um delayzinho e tal.
Não, com este software, eles até dizem que o delay é frames, não é sequer é segundos. Só fazemos com Jitsi, com Teams, uma coisa dessas. Aí tens um delayzinho. Sabe, por acaso até nem interessava. Mas como tem um vídeo, depois não vai aparecer coisa desincronizada, ou pôr uma coisa mais profissional.
Ora bem, então precisavam de 3 destes
Eu até
PCs.
levo o meu, faço fazer broadcast do meu, fica lá um canto, levava 2.
Ok.
Estás com pressa?
Estou com um bocadinho. Posso ir?
Pode ir.
Obrigada.
Muito obrigado.
Pronto, também há.
Também há.
Setup.
Depois amanhã de manhã trazemos, não é? Trazemos depois para amanhã de manhã.
Assim, ia tentar só levar 2. Aquele da sala ao fundo, que até acho que é da matemática, não?
O branco, sim.
Levo o branco, porque amanhã não é preciso, não acredito.
A outra sala do lado já não tem, também já não é usada.
A outra sala também já não é usada.
A outra foi aquela que só foi usada um dia.
Sim.
Mas esse nós já levámos, o PC10, e esse era fracote.
Mas, por exemplo, levo este e levo aquele, eu amanhã não
O da matemática, ele estava com um problema, estava sem licença de...
as pessoas queixam que ele começou a pedir.
Estava sem licença, mas nós tentámos pôr, mas não tínhamos password de administrador. Por isso aquilo estava minado. Vamos.
Não, vocês preparam os vossos bem, para aí não aparecerem nem atualizações. Nem
claro, desligamos as atualizações.
É tão...
Tem que ser.
Tão simpático.
Tem que ser. E pronto, este aqui, qual é que é este? Eu tenho lá o...
Isso não tem o autocolante?
Deve ter saído, porque estes autocolantes já são um bocado antigos. E acho que eles estavam a descolar. Ora bem, esta sala é a... 112. Por isso este é o 03.
Sala é 112.
Ok, pronto. Pronto, vai esse então. Vai esse. Depois talvez se havia algum, mas algum que fosse melhor levar. O outro já está desligado, do auditório, também podia ser o do auditório.
Está lá abaixo?
Sim, do Belno. Mas cá levámos um daqui, não é? Depois...
aqui.
Aqui ao lado, parece que o problema que a pessoa que ficou de apresentar estava-lhe sempre a cair da net. O rapaz estava-me a dizer que depois, como no show, apesar dela estar, porque não houve mesmo apresentação, porque ela começava a falar e aquilo caía dela.
Net dela, sim.
Não sei se temos que ter a doutora.
Não, mas o Damiano é que trata disso. É com o Damiano.
Ele faz a gestão das sessões, não é?
Ele está lá e ele está no
rapaz que no show, não sei, não é? Se temos que fazer alguma coisa.
Isso não depende de nós.
Exato.
Olha, mas eu ainda não tive nenhum no show. Está toda a gente a aparecer e a falar e remotamente a conseguir-se. Epá, estes microfones funcionam muito bem.
A sério, nós lá.
Olha, em 3 salas, já fiz em 3 salas diferentes. Olha, perguntas lá atrás, perguntas aqui de lado. Capta bem.
Na nossa sala stream, experimentamos com aquilo também, funciona um bocadinho. E é igual com o outro. Mais ou menos os mesmos preços, mais ou menos igual.
Eu não sei se é tudo mais ou menos igual.
O senhor que instalou tudo isso.
Exato. Vendeu a
coisa, sim.
50 mil euros, espero que ao menos o gasto tenha algum
microfone. Exato. Não metam um microfone das pessoas.
Olha, acho que estavam todas, não é?
A Ana diz que tem um carregador, tem o carregador dela. Ora bem, estes portáteis não têm cá os carregadores. É o único problema que nós temos.
Vocês já levaram?
Os carregadores estão lá em cima, porque eles estão com USB-C.
Exato, exato.
Cá. Por acaso havia um que tinha carregador, qual é que era?
Não estou claro. Mas era o mais velho, era um antigo.
É.
Isso quantas horas tem? Se calhar chegar ali umas 4 horas.
Não vamos.
Com projetor. Não. Mas espera aí, eu tenho...
A Ana Rocha disse que tem um carregador USB-C.
Então chega. Eu tenho aqui outro da matemática, fui buscar. Este é da matemática. Eu fui agora buscar. Que estava na sala 115.
O branco?
O branco. Este é o carregador do branco. Portanto, eu vou levar o branco que tem carregador. Para este, peça a Ana Rocha.
Pronto. Ok.
E para o meu tenho o meu.
Ok. E amanhã atrás temos os normalmente.
Sim.
Amanhã trago.
É o desta e o do branco.
Eu já decidi que não vou ver futebol, portanto.
Não,
Não, é que se formos todos ver futebol amanhã isto vai estar aqui tudo cadáveres, ainda precisamos aqui corre mal, Jesus.
Ok.
Está bem?
É. Tchau.
Tchau, olha, muito obrigado. Oi. Really slow. Estou sim? Sim. É Jorge Rocha. Não, não, quero fazer isso, quero melhorar o serviço, sim. Mas olha, agora não me dá jeito tratar disso. Pode ser para a próxima semana? Ok, pode ser assim. É manter tudo igual. Exatamente. Isso é importante. Ok, ok. Tá? Muito obrigado.
Tá, muito obrigado.